For two balls colliding towards each other, this is the equation we derived in the previous video. The total momentum before the collision is equal to the total momentum after the collision. Pause the video and go through this problem. Before we go ahead with the problem parameters, let's visualize the situation first. Two clay balls are moving towards each other, and they collide to become one. Let's stop here. We haven't discussed what happens after they collide. Let's assume that the ball on the left is the first ball and the ball on the right is the second ball. The first ball is moving to the right and the second ball is moving to the left. Okay, let's talk logic. If the momentum of the first ball is more, in which direction will the combined lump move? Obviously to the right. And similarly, if the momentum of the second ball is more, the combined lump will move to the left. Now that you've understood the concept, let's begin with the problem. This is the information about the first clay ball, and we've been given data about the second ball as well. We assumed it's -20 because it's moving towards the left. Now look at the formula we looked at while understanding the law of conservation of momentum. The value on the left is the total momentum after the collision. As the two balls become one, the velocity at which they will move after the collision will be the same. So V1 will equal V2 and say they're equal to V. Now let's substitute the values in this formula. Substituting the values of M1, M2, U1, U2 gives us this. The value of V is what we've been asked for. What is V? It is the velocity at which the lump moves. The left-hand side will equal 250 times V and the right-hand side will equal 1500 minus 3000. We get 250 V as -1500. And that gives us the value of V as -6. Wait, don't forget the units. It will be -6 centimeters per second or -0.06 meters per second. What does this negative sign tell us? It tells us that the combined lump will move in the direction of the second ball at the velocity of 0.06 meters per second.